Hello everyone, welcome to School Math Simplified. We are continuing our chapter number 5, number play, and we are on the topic taking divisibility quickly. So, in earlier classes, you have learned about the divisibility rules and the according to Indian number system, the divisibility of 2, 4, 5, 8, and 10. I hope you will revisit them well, and now we'll link this with the some quick facts of algebra, right? So divisibility by 10, 5, and 2. If the unit digit of the number is 0, then it is divisible by 10. This is known to all of us, right? Now let us understand why this works through algebra. Now there is a twist, okay? We can write the journal form of a number in the Indian system using a set of letter numbers. How? I hope you are aware about expanded form of any number. So what is expanded form? If you have like 999, the expanded form will be the place value into the number plus place value into number plus place value into number, like this. This is what we call the expanded form, right? So for example, you have a 5-digit number that can be expressed as EDCBA. This is nothing. There is nothing new about EDCBA. This is just a number taken in the form of algebra. Like, this is any random number, any 5-digit number, random number, E, D, C, B, A, where A is at unit place, tens place, and C is at hundred place, D is at thousands place, and E is at 10,000. Okay, so this is what a number is taken in algebraic form, and the letter numbers EDCBA denote each digit of 5-digit number. So any number can be written in journal as DCBA, where the letter numbers A, B, C, D represent the units, tens, hundreds, and thousand digits respectively. That's what I have already told you, right? As the sum of place values, the number will be 10,000 D, 100 C, 10 B, and A. This is quite obvious, right? If you have E, D, C, B, A, this means 10,000 E, 10,000, 10,000 E plus 1,000 D plus 100 C plus 10 B plus single A, right? This is what we call the expanded form. Now we know that each place value with the exception of unit place is a multiple of 10, right? Exception of unit place, obviously each unit place is a multiple of 10 except this, right? So 10B, 100C, all will be multiples of 10. Hence, the number will be divisible by 10 if and only if the unit digit A is 0. Now, it all depends upon A, whether the number is divisible by 10 or not. If A is 0, then we can say that the number will be divisible by 10. Clear? Now, similarly, explain using algebra why divisibility shortcuts for 5, 2, 4, 8 work. Now let us examine shortcuts for this. Now we are moving to the shortcut for divisibility by 9. So what is that? Now you must know that any number with the combination of 0 and 9, they are 100% divisible to 9. 100% divisible to 9. Why? Because the divisibility rule of 9 says sum of all digits, sum of all digits must be divisible by, must be multiple of, right? Must be multiple of 9. Only then we can say the number will be divisible by 9. Now, in this form, when the number consists of 0 and 9 only, clearly the sum addition of all the digits will be a multiple of 9. So the number will be 100% divisible to 9. Yeah. Now, nextly, can we say that any number made up of only digit 0 and 9 is divisible by 9? So, yes, 100% yes. If each digit is either 0 or 9, it will be divisible by, or it will be a multiple of 9. If we have 99009, so the expansion of this will be like this. But this shortcut alone cannot identify all the multiples of 9. Unlike the numbers 2, 5, and 10, we cannot identify the multiples of 9 by just looking at the unit place. Like if I have 99, yes, this is divisible by 9. But if I have 109, its unit place is 9, but the number is not divisible to 9. Are you clear? In 10, in 2, 5, and 10, when we check the divisibility of all these three numbers, we can only check the unit place and can answer yes or no, answer in yes and no. है ना? We can answer in yes and no by only watching the unit number. But in this case, only unit number is not enough to check the divisibility by 9 or not. Are you getting that? Is 10 divisible by 9? If not, what is the remainder? 10 is not divisible by 9. This is always clear to all of you, right? Now check the divisibility of other multiples of 10, like 10, 20, 30, and so on. Now just have a look at these things. When you divide 10 by 9, you will get remainder 1. When you divide 20 by 9, you will get remainder 2. When you divide 30 by 9, you will get remainder 3. Don't you think the remainders, these are the actually same as the number of tens? Like if I have one ten, the remainder is 1. If I have two tens, 20 means 10 plus 10. Na? If I have two tens, the remainder is 2. If I have three tens, the remainder will be 3, and so on. And same will happen with 100. If I have 100 to be divisible by 9, then just observe what kind of remainders you are getting. You will get what idea it is. Okay. Now, like you have 427 and you need to find out the remainder of this when divisible to 9. Now, this is a good thing now. See, 427. In 427, 400s are here. है ना? There are 400s, two tens, and obviously 7 is here, 1 7, right? This is here. Okay. 7 ones, sorry, 7 ones. Yeah. Now if you have 400s, that means the remainder will be 4. If you have two tens, the remainder will be, corresponding remainder will be 2. If you have 7, then the remainder will be 7 is itself will be the remainder, because if we divide 7 by 9, the 7 itself will be the remainder, right? Now we have three remainders, but we need to find out the remainder of 427 compiled, right? So the formula will be add all the remainders, 4 plus 2 plus 7, which is 13. Now use 13 as a group now. Now divide 13 by 9, you will get 4 as a remainder. Are you getting that? So this is a way to find out the remainder of three-digit number. Clear? Next. Will this work with the bigger numbers? So let's check out. Like you have 7309, any four-digit number. Just add up all the digits as you get 19 here, 19 here. Clear? Now add again it, you will get 10. When 10 will be divided to 9, you will get 1 as a remainder. So this is a trick. Clear? This is a way to get it. This is in the whole text, it is elaborated. You can read it. Okay. Now look at the following statements which are correct and why. If a number is divisible by 9, then the sum of its digits is divisible by 9. So just check it out. If a number is divisible by 9, say 18 is divisible by 9, then the sum of its digits is divisible by 9. So I think it's true, right? It's true. The sum is divisible by 9. If the sum of the digits of a number is divisible by 9, then the number is divisible by 9. So yes, this is also true, right? If a number is not divisible by 9, then the sum of its digit is not divisible by 9. So this is a negative form of this statement, of the above statement. If the number, like say 16, is not divisible by 9, and 1 plus 6, which is 7, obviously this is also not divisible by 9. And if the sum of the digits of a number is not divisible by 9, then the number is not divisible by 9. So, all this is leading us to only and only one result, that is the divisibility rule of 9, that you already know. Divisibility rule of 9. That is, the sum of all the digits should be the multiple of 9. Now, let's start with the figure it out. Question number 1. Find without dividing whether the following numbers are divisible by 9, like 123. 123, adding up the digits, 1 plus 2 plus 3. This is 7. No, this is 6. So obviously no, right? This is not divisible. 405. 4 plus 0 plus 5. Yes, this is divisible. Sum is 9. So yes. 8 plus 8 plus 8 plus 8. 4 times 8. That is 32. This is not divisible. So no. 9 plus 3 plus 5 plus 4 plus 7, which is 28. So it is also not divisible. Now for this, 3 plus 5 plus 8 plus 0 plus 9 plus 5. It is 30. So again, no, this is also not divisible by 9. Clear? So this is the answer of first question. Now moving to the next question, second question. Find the smallest multiple of 9 with no odd digits. You need to find out the smallest multiple of 9 with no odd digits. What are the multiples of 9? These are 9, 18, 27, 36, 45, and so on, right? See, in every multiple, 1 is odd here, 7 is odd here, 3 is odd here, 5 is odd here. You will get odds, right? And you need to find out the smallest multiple of 9 without odd digits. So the number is 288. The number is 288 is the smallest number. The answer of this is this. Okay. Moving to next question. Find the multiple of 9 that is closest to the number 6000. See, to be the multiple of 9, the sum of the term should be a multiple of 9. For this number to be a multiple of 9, the minimum term that we should add is 3. If we add 6 plus 0 plus 0 plus 3 here, it will be 9, right? Which is a multiple of 9. Then it would be the closest to 6000. Are you getting that? So 6003 is closest to 6000 to become divisibility by 9. Clear? इन्होंने ये पूछा है कि 6000 के नियर 9 का कौन सा मल्टीपल है. नाउ हमें इतना टेबल नहीं आता है, तो हमने क्या किया, 6000 में सबसे छोटी वैल्यू वो ऐड कर दी ताकि हमारे जो डिजिट्स का सम बने वो 9 का मल्टीपल बने. क्लियर? तो that's all for this. Fourth question, how many multiples of 9 are there between 4300 and 4400? You need to find out the multiples of 9 between this. So 4300, see firstly, 4300 means addition of the terms will be, is, here it is 7. तो व्हाट मिनिमम नंबर टू बी एडेड टू गेट द मल्टीपल ऑफ 9? 7 में क्या ऐड करें? 2 ऐड करके 9 बन जाएगा, राइट? दैट मीन्स सबसे छोट मतलब इनके बीच में सबसे पहला तो ये नंबर आएगा 4309। अब बाकी के नंबर फाइंड आउट करने के लिए 99 ऐड करते रहो सब में। 9 नेक्स्ट नंबर फाइंड आउट करने के लिए इस नंबर में 99 ऐड करते रहो, आपको 9 के मल्टीपल्स मिल जाएंगे एंड दे विल लुक लाइक फर्स्ट नंबर विल बी 4302, इसमें 9 ऐड किया 4311, इसमें फिर से 9 ऐड किया 4320 एंड सो ऑन। ऐसे ही लास्ट नंबर बनेगा 4392। और ये मुझे कैसे पता चला? जैसे मैंने 4400 का जब ऐड करोगे तो क्या बनेगा? 8, 8 बनेगा। और मैं ऐसे इसमें से सब्ट्रैक्ट करना है क्योंकि हमने इससे छोटा नंबर फाइंड आउट करना है। आर यू गेटिंग दैट? इससे इसमें ऐसा नंबर फाइंड आउट करना है कि मेरा वो डिविजिबल बाय 9 हो जाए। तो सम ऑफ टर्म्स 4400 से छोटी टर्म फाइंड आउट करनी है। 4400 से छोटी 4399 होगी, ऐड करके चेक कर लेना। फिर 4398 होगी, 4397, इन इन सबको चेक करना पड़ेगा। व्हेन यू ऐड ऑल द डिजिट्स यू विल गेट टू नो कि 4397 ही सबसे 4400 से छोटा नंबर है जो मल्टीपल ऑफ 9 है, ठीक है? तो ये कितने हैं? हाउ मच आर दे? तो यहाँ पे एक ट्रिक फॉलो होती है। क्या ट्रिक है? सी, द ट्रिक इज द नंबर ऑफ multiples of 9 is equals to, the trick is last term minus first term upon difference plus 1. This is a trick. Okay. So now what is the last term? Last term is 4392. And what is the first term? 4302. And the difference is 9. Obvious? Right? So solve it. It gives us 90 upon 9 plus 1. So when we solve it, 10 here. So 10 plus 1, it is 11. So there are 11 terms. How many multiples are there? 11 multiples. Okay. There are 11 multiples of 9 between 4300 to 4400. I hope you are clear with this, and in the next lecture we will continue doing the next shortcut tricks for divisibility by other digits. Fine. Till then, do this, figure it out, and if you need any help, you can comment to comment section.